Hi everybody, this is video number 13. I'm going to try and do a recording just now. I have road workers outside my window. Let's hope they don't disturb us for the next few minutes. We're going to be talking about powered nailers now. Cordless nailers and angle brad nailers, they're absolutely essential. Of course, cordless are not the only type that can be used. Very often when it comes to working in factories, these can be powered by electric. But cordless nailers are very common on building sites. There's two sorts of cordless nailers. There's the cordless nailer whereby the impact, is actually just horizontal to the the nail gun, and then there's other types in which the nail gun is at an angle. See that? And so it's able to get into corners a lot easier. It's called an angled brad nailer. And these are generally speaking powered by gas, but there are versions powered by battery. In fact, there needs to be a battery anyway on these nailers to make the nailers work. There's not really a great deal to say about nailers, funnily enough. They're very, very simple to operate. You have a safety device on the nozzle whereby it cannot be depressed accidentally. It has to be pressing down onto a surface in order for the whole thing to work. We have a nail magazine, and these nail magazines come in various varieties. They come either with all the nails set in a line, or they come with all the nails set on an angle. Of course, they're for two different machines. One's for the cordless nailer and one's for the angled nailer. The type of fixings that are used, they can be powered nails, so they can be nails that are power driven, or they can be pins or brads that are powered driven. The ones that I use in the main are pins and brads, and they can be anything up to 3 inches long, so they're really quite a substantial tool. There's a few other types of fixings. First of all, the star dowels. Now, star dowels are something that's driven into a woodwork joint to enable it to not be able to be taken apart. Once these star dowels are embedded in a joint, it's impossible to actually extract that joint. Staples. Now, staples go into thin plywood, they go into thin material. They are exceptionally useful, and a good quality large stapler is exceptionally good. I mean, I had a stapler for many years. Always buy the biggest one that you can find, and always make sure that there's a good supply of staples. I think I bought 15,000 staples initially, and I think I've still got some of them left. You know, sometimes these things go on and on. Now, the next thing we need to talk about in operating tools is planers. Now, planers are actually a very, very old-fashioned tool, but they have been brought into the modern era. And planers are really great for on-site work. They have a large adjustment knob at the front. This we use as a handle as well as adjusting, and they have then a large sole. They're normally about 12 inches long or 300 millimeters long. They have lots of attachments, so you can get attachments so that they can cut rebates or so that they can cut flat with a fence. Of course, they have a trigger. Sometimes the trigger is able to be electronically controlled, so the more pressure you put on, the faster it goes. The more you release it, the slower it goes. And also they have a little trigger whereby you can turn it on and click it so it stays on. You haven't got to keep holding onto it, squeezing it while you're working with it. So brilliant tools, various types. You can cut on a splay, you can cut chamfers, you can cut bevels, and you can cut rebates. These are all the cuts that can be done with an electronic planer. Just beware when you're using an electronic planer that if you go very fast, then you will get a ripple effect. As the cutters come around, they don't have enough time to come around before you've moved on. If you go a lot slower, you get a much smoother effect. Now, the step-by-step guide for replacing planer blades is something that's best looked at in the tool instructions, which will be with every tool kit, with every plane. There are slight variations. Some of them need Allen keys, some of them need little spanners. They normally supply a spanner especially for that. So follow the manufacturer's instructions and be very careful that you read all of the manufacturer's instructions. The next tool is routers, and of course routers are able to do grooves and housings and profiles. Essentially a router is a big motor attached to a cutter via a collet. Some of these machines are very big and some of them take a while to fully get up to full speed. All of them pretty well now are able to be adjusted for speed so that you can slow them right the way down or you can speed them right the way up. I normally have them at a fairly good pace. We want to be able to clear the debris quite quickly. They all have a fine depth adjustment, generally speaking, and this is something to just get used to being able to plunge with them and hold them at that point and then release and lift them. All of them nowadays have a really good quality fence. You wouldn't expect carpenters to be buying very cheap versions of a router, but I will say that some routers do actually have a really good operational life, even if they're quite small, because they can do quite small and delicate operations. Now the switch that's used to operate a router, generally speaking, the switch is very close to either the right or left hand, and this enables you to be holding it in your hand and flick the switch without having to take your hand off the router. That's very important. We don't want to have to switch it on at the top. We want to be able to switch it on where our hands are. This gives us a lot of control. The handles are usually a very, very firm grip. They're large and we need to hold on to them fairly firmly. But the most important thing we need to understand is this, is that we don't start up a cutter, okay, when it's in contact with the wood. This is a given with all routers. What we do is we make sure the cutter's not in touch with the wood. Maybe it's lifted up or maybe it's lifted to one side. We turn the machine on. When the machine reaches its full speed, then we either drop the cutter down into the wood to move, or then is the time when we, at full speed, attempt to cut through the timber from the beginning to the end. And what we do, we never allow the cutter to slow down while it's in contact with the wood. So we always then bring it right away out of the other end to stop it, or we lift it right the way up, let the cutter clear the wood, and then reclip it so that it then will slow down. And these routers, they can be spinning at a fair old whack, so we don't really want to be stopping and starting when we're in contact with the wood. Now the collet is a funny little thing. What the collet does is it holds the cutter into the machine, and these cutters come in mainly two different sizes. So we need to have a collet that's the correct size, okay, so that it will be able to hold the cutters in place. There's various other ways in which the tool can be used. One of the most obvious things is, how do you take a cutter out? Well, first of all, you must make sure that the whole machine is unplugged from the power source. That's the first thing. And then once that's done, normally there is a button that you push which locks the spindle from the motor and stops it from moving. And once you push the button, you then can get a spanner and you can turn it a couple of times and the cutter will pop out. Okay, this is a given thing. This is found in all of the instructions in all of the manuals that you will see. Now there are quite a lot of different cutters. I'll just read out some of them. There's Ovolo, there's a rebate cutter, there's a chamfer cutter, an astragal cutter, a V cutter, a dovetail cutter, a trimming cutter, a flute cutter, an OG cutter, and a Cove Scotia Cavalot cutter. So that's just a few of them, but there's mainly two different types amongst them. There are those cutters that are just a cutter, so they just have the high quality tungsten steel on the side. Sometimes they're on one side and sometimes they're on both sides at the same time. But there's another form of cutter, and that is the same thing again, but coming down through the bottom of the cutter there will be a small wheel race, which means that the cutter then can roll along the side of timber, and it won't move into the timber as you're cutting. You can roll the wheel along the timber, and that wheel will give a very accurate measure. You don't really need to then have a fence, because that little wheel will come against the side of the wood and will roll along. It's particularly useful, very useful, when you're doing a flush cut. So the flush cut cutters have a ball bearing race, and they have a cutter that's exactly the same size as the ball bearing race, and that means that they can come along the side of wood and they can cut off any surplus material and leave it perfectly, and I mean that, perfectly in line with the edge. Okay, now routers are particularly useful to us. I mean, there was a time when we had all sorts of tools available to us, different types of planes and devices. They had little hand routers. The electronic router has pretty well taken the place of all those devices, and so it is now an exceptionally useful tool, and every joiner will become familiar with it. The other thing that's become very popular is to take the router and mount it upside down on a table. Now, I've done this many times. I've mounted it upside down onto a piece of strong timber that's attached to a table, and by putting a fence across it, you then have, you know, a really useful device for passing timber through. But there are actually professionally made router tables. Some of them are not great in the very lowest end of the market, but some of them at the top end of the market are exceptionally good indeed, and we highly recommend them. There's really three types of cutters again, like we talked about before. There's TCT, which is tungsten carbide tipped, which is the most common of all, but there's also HSS, or high-speed steel. High-speed steel is fine for doing most work, especially with softwoods. But there's also the PCD, the polycrystalline diamond. Now, these cutters are exceptional. They're quite expensive, but they are exceptionally good, and they have a very, very good long life. It's very important that when we're using cutters that we do not overwork them. So, for example, when a cutter is going to be cutting into timber, you don't really want to be cutting no more than about 2 or 3 millimeters at a time. You don't allow a large cutter to cut large sections. The cutter's going to find it very tough. The motor's going to find a lot of resistance. It'll get very hot. So far better to let it do a number of strokes, increasing the depth as you go. It's the same with a planing machine. You wouldn't want to be cutting off, 5 millimeters at a time. No, you'd do it in a couple of millimeters at a time, and that would give the machine an opportunity to be able to cut sort of in a way that's within the scope of the motor of the machine. So there's lots of questions you need to ask yourself. You need to ask yourself, what's the type of timber I'm going to be cutting? Is the timber very hard, or is the timber very soft? Don't be deceived by the words hardwood and softwood. Sometimes hardwoods can be very soft, and some softwoods can be very hard. So we need to ask, is the wood hard, or is the wood soft? Okay, that's the particular point. If we're using a tool correctly, we will find that almost invariably the cutter doesn't get too hot and doesn't leave scorch marks on the timber. And so there we are. That's the router. Obviously, there's lots of different varieties of router, and one of the most important aspects of a router is that it has jigs. And the most important router that you'll come across, first off, is the jig that allows you to use templates. So this is a small circular device which fits on the underneath of the plate of the router, and it has a collar. Now that collar is able to run along the sides of jigs. And what that does, that gives you an opportunity then to be able to use all sorts of jigs. You might, for example, use a jig for making worktop cuts, you know, like when you put the curve cut on a kitchen worktop, or you might use it for doing curve cuts in, say, jigs for doing hinges or jigs for doing dovetails. All these tools are really great, but it needs to have what's called the bush jig, and this is a device that fits on the underneath of the router. They normally are supplied with the router, so you don't need to worry about something fitting correctly, and it's normally fitting with just an a posi drive bolt, just a very tiny one on each side of the jig, and that's basically how they're used. Okay, so we need to push on with some more tools. We've got sanders. Now everybody knows what a sander is, and everybody thinks, oh, they're great, you know, they're easy, they're dead easy to use, no problems with safety. Well, actually, as I'm sure you're aware, the sander can actually do some harm if it comes off and touches you. It's a very coarse grit, generally speaking, and it's travelling at quite a rate. So if it comes in contact with your skin, it's going to have no problem in just cutting through your skin. So a sander then is something to treat with a certain amount of respect. There are mainly two types of sander. Well, two, maybe three or four, but we'll just go through the types. First of all, there is the belt sander. So this is a sandpaper, if you can imagine, that has a complete circular feature, and it goes onto a sander, and once you turn the sander on, that belt's going to whiz around continuously. Now what we need to then do is to be very careful that we hold it in such a position that it's not, you don't need to push down. Almost invariably a belt sander is very coarse, and it will cut through material very, very fast indeed. So what we do, as we hold it as in mid-air maybe a little bit, and then we gently lower it onto the timber, and we allow it to just skip over the top as if it's like a hovercraft. It's just basically floating across the timber. We need to make sure that most of the time, nearly all of the time, we're going with the grain of the wood. If you're going across the wood, the belt sander, you may not even see them, but they'll leave tremendous amount of scratches going across grain. And if you're going to be doing something that needs to have a decent finish, then you need to be going with the grain. And you also need to make sure that you're not pressing too hard. I can't emphasize that enough. Taking the belt out is a very simple thing. Normally at the side of the machine there will be a large lever. You pull the large lever out, and what happens is the two wheels come closer together. Normally it's the front wheel that moves closer, and the effect of that is that the belt then becomes loose, and you can gently feed it out and put a new one in. At this particular time it would be good to give it a good blow through, get some of the dust off it. Make sure though that when you put it back in, that you put the belt in the right way around. If you look at the belt, you'll see that it'll have a long arrow pointing in which way round it ought to be fitted, and make sure that the belt is put in the right way around. That arrow should always be going forwards. It should never be going backwards. And you see what I mean? So put that back in, put the lever back on again, and then just tentatively start it a little bit, just a little flick to see which way it's moving, and you'll discover that sometimes you'll have to do the tracking. So there's a little knob near the front that you just wind either way, just a tiny little bit, and what this does, this causes the belt to move backwards and forwards on the wheels. And what you're wanting that belt to run in the center of both wheels. Okay, now the sanding belts come in lots of different grit sizes. I mean, for example, P60 to P80 is for really rougher work and for stock removal. If you want to take a lot off, want to take a lot of paint off wood, for example, then that's the one to use. 100 to 120 is generally for fine finishing work, but you can get 180 to 240. Now these are exceptionally smooth, very smooth indeed, are generally used on hardwoods or on furniture finishing. Okay, so then there's the orbital sander. Now the orbital sander, beautiful little device, been around for a very, very long time. And what it is, it's a small motor that has inside it a little weight that's on a spigot. And that little weight has a tiny little bit of metal that's actually just off center. When it's turned on, that thing tends to go eccentrically, so it doesn't really go in a smooth line, it sort of wants to wiggle. The effect of that is that when you turn it on, the sandpaper then is not going in a large circle, it's actually just shaking, it's nearly shaking. But when you put a little pencil line on it, you'll see that it's going in a little circle, little tiny circle. Now the thing about the little hand-operated orbital sanders are that they're great for very fine and smooth work. You never really want to be using them in such a way that they take off a lot of material. They're used for final finishing. There's a knob usually at the front and there's a handle at the back, so you can get some good control over it. And generally speaking, they come with a dust bag, so that can eliminate some of the dust that comes off the machine. The dust is going to be very fine and you don't want to be eating that. Sometimes we have other types of machines. One is called the random orbital sander. So it's an orbital sander just the same, except that not only does it turn in a little circle, but the whole machine is also turning in a larger circle. So this is much more random. This means that the effect of the sandpaper is that it has much more contact with the timber and is able to produce a much more even finish. A lot of these machines are able to have automatic dust extraction now, either through the plate on an orbital sander or through the large disc on a random orbital sander, and it will suck up the dust that's being cut on the timber and put it into the bag that's attached. This dust that's coming up is actually quite a useful resource. It's something that we need to sort of put a dust mask on when we're using it, and then we then need to collect it. We can pop it into a little tin or something. It's very fine and it can be used for all sorts of purposes when you're finishing timber. Okay, a lot of the storing of portable power tools now is done in special boxes that the manufacturer supply with the tool. These all come in different sizes, and some companies are even doing them whereby all of them are interchangeable boxes. So you might have 4 or 5 different boxes and they're all able to stack on top of each other and clip together. This is exceptionally useful, and it enables you to look after your tools really well. Now we need to talk about fixed machines, and we're going to talk first of all about the circular saw. I expect some of you were wondering when we're ever going to get to this subject, because the name of the unit is set up and operate a circular saw. So we're now going to cover that just now. The most important thing is with a circular saw is to begin to know what all the different features of a saw are for. They almost always have a universal name. So for example, you've got the riving knife, you've got the top guard or the crown guard, you've got the top extraction, you've got the saw fence, you've got a cross-cut fence or even an adjustable fence, you've got the stop and start buttons, you've got the extraction, you've got the rise wheel, a rise and fall wheel. You've also got an isolation switch right next to where you're working. This means that you're able to turn the machine off completely and there'll be no power going to the machine at all. There's also guards for the belts and pulleys. So inside the machine there will be various moving parts, and there's always a guard over that to make sure nobody gets hurt. Sometimes there's an extension table attached, and nearly always there's a groove for the use of a fence. Okay, so these are all the parts. I can't show you right now, but you can go to a fixed large circular saw machine and you can identify all these parts on it. Before a machine is ever used, there's sort of like a pre-use checks. Let me tell you about some of them. The first is to make sure there's nothing missing. Make sure that that machine hasn't got a guard missing. Make sure that everything is working correctly. Sometimes if the machine has a crown guard, there will be a small extra extension at the nose of the crown guard, which should come down quite close to the surface of timber being cut. And that really needs to be adjusted. And with circular saws, the numbers are always 12. We need to make sure that 12 millimeters at least is the, no more than 12 millimeters is the gap that you have when you're ripping with a circular saw. Some people say you need to bring it down as close as possible. Well, if you bring it down as close as possible, you might just find that the one end of the timber is a little wider than the other end, and then what you're going to find then is that the wood will jam underneath the crown guard. So we recommend that you stick to 12 mil. 12 mil is not very big. Stick to 12 mil, and that will almost always be sufficient for you. And what I do is I always have in my pocket a little piece of timber specially made that's 12 mil. What I can do with that is I can put the timber on the saw, put the little piece of stick on it, bring the crown guard down to the top of it without even measuring it, just tighten it, take the stick away, and I know that it's set at the correct height. So make sure also there's nothing faulty about any of the electrics or the plugs. Make sure that all the switches are working correctly, and finally have a look at the blade before you turn anything on and just check that it's in a relatively decent condition. You'll be surprised how people sometimes leave a saw in a relatively poor condition. So they might leave a saw with teeth missing, and some saws can have up to 3 or 4 teeth missing, or maybe a saw that isn't got a tooth missing but a tooth that's misshaped. And this is known by an operator. If, for example, you're putting some timber through and you hear a big clunk, then you'll know it's hit a nail. Okay? And if you hear that big clunk, you don't just walk away from the machine and let somebody else sort it out. You really need to be looking at it yourself. Now, saw blade parts. Without going through long detailed drawings of this, there are a few things you need to look at. You need to, we talked previously about positive and negative hook on a sawtooth. If, for example, a sawtooth, when you take a line down to the middle of the blade, if the sawtooth is leaning forward, that's called a positive hook. If it's actually leaning slightly back, that's a negative hook. But you do very occasionally, very, very occasionally, have a tooth that's perfectly upright at the front. That's unusual, but they exist. You need to know really that there's on a tooth you've got the tip of it. We all know what the tip would be. That large space in front of a tooth is called the gullet. And the front of the tooth is called the face. Okay. The back of the tooth, okay, is always called the heel. And the top of the tooth is always called the top, and the bottom of the tooth is always called the root. Now, the gullet is very important, and it's very important when using tools that you do not that you do not allow the gullet to become full of resinous sawdust, because that gullet is not just there for show. That gullet is part of the operation of the saw, and it creates a small vacuum which enables the dust to be pulled away from the tip. Okay, so that gullet needs to be kept quite clear. Now, obviously a saw has a riving knife, and you need to look at the manufacturer's instructions, but I'm going to give you the regulations. The riving knife must be on the saw. That's the first thing. And the riving knife will have a very slightly larger thickness than the thickness of the kerf. The kerf is the gap that the gap that the saw actually cuts out of timber. Okay, sometimes you have a tooth going one way and a tooth going the other way, but the main point is over the two is called the kerf. Okay, and the riving knife should be something in the region of about 10% larger than the thickness of the kerf. Apparently, that's what I understand. Now, the main thing is the riving knife must come up to the back of the saw, right, to only a maximum of 25 millimeters from the top of the saw. You can't have a riving knife that's really small on a large blade. It's got to come up quite high, and you can adjust these things, and you've got to get it to within 25 millimeters of the top of the blade. The gap between the riving knife and the cutting circle, okay, in this particular book says 8 millimeters, but I'm not sure that that's exactly the right thing. I've always understood it to be 12 millimeters, but the important thing is that at least we have it very close to that. Between 8 and 12 is a very small number anyway, but the important thing is we don't have a large gap. Okay, we must not have a large gap. Small bits of wood can actually turn in between the saw and the riving knife, and if that happens, then you've got an accident happening right in front of your eyes. Okay, so there we are. The other thing that we need to note about all these different machines is that when you look at the machine, there is by law a notice on the side of the machine telling you what is the maximum size of a blade that can be put into the machine, and also a minimum size, maximum and minimum. And it's very important that we have the right size blade put into a saw, because if you lower the size of the saw, then it alters the speed of the circumference. Okay, it alters that speed. It makes them go faster or slower. Now, I can't actually demonstrate changing a circular saw. It's one of those things that is better seen than talked about. Much easier to talk about it than it is to see it when you're on a video. But these are the basics of what you need to know about the circular saw. There's a few more things we need to talk about, but we'll talk about those on the next video. So look forward to speaking to you next time. Have a great day. Bye for now.